welcome to this video. I'm going to walk you through the electric field lab. The first thing we're going to do is open up this PhET simulation called electric field strength. So you can just do a Google search for PhET, electric field strength. The first thing that pops up, charges and fields, that's what you want. There's this play button. You push the play button and hopefully something loads like this. If this doesn't load, oh no, it's HTML. This should load. Over here on this side, we have all these positive 1 nanocoulomb charges, negative 1 nanocoulomb charges, and electric field sensors. Okay. Now we're going to click Grid, Show Numbers, and Tape Measure. Okay. And there's the tape measure, just popped up. I'm going to drag a single 1 nanocoulomb charge right over to here. And I'm going to put it on the grid line. And then I'm going to grab an E-field sensor, and this is what I use to measure the field at different locations. So I could test the field right here. I could test the field a little farther away or even farther away. Now, when I place this thing at some location, the arrow is showing where the field points. Right, so that's where the field points. And then this value, 56.1, that's actually the electric field strength. Field strength can be measured in volts per meter or newtons per coulomb. So 56.1 volts per meter is also equal to 56.1 newtons per coulomb. So here's what we're basically doing. We're measuring the electric field strength at different locations away from this source charge. Okay, so every time we place our sensor at some location, like let's say we start out right here, there are two values we need to collect. We need to first use this tape measure to get the distance between the center of the charge and the center of the field sensor. So see how I've lined up this red cross with the center of this charge, and the second red cross is lined up with the center of the sensor. So that distance is 0.206. And how strong is the field with this as the distance? The strength is 220.3. So 0.206, 220.3. I'm going to put this into an Excel chart. I'm going to have R in meters and electric field strength in newtons per coulomb. My R was 0.206. Notice that I do not put an M into this box, just numbers. And my value for strength was 22.3, like this. Okay. There we go. And then I move my field sensor a little farther away, right? And I measure the new distance. So now at 0.4, it's 56.5. So at a distance of 0.4, the strength of the field is 56.5. And I continue in this fashion until I have 8 trials. Okay, so here we are. Let's say that I've collected my data, and this is what it looks like. If you want, you can do the center, use the center buttons here to center the text. And the other thing we should do is these values were all collected using the same device, the tape measure. So we need to make sure they all have the same precision, the same number of decimal places. So under the number tab, I use this button to increase or decrease the number of decimal places. Now, the most decimal places any value had from the tape measure was 0.206, so that's 3 decimal places. So they should all have the same 3. Likewise over here, these should all have, I think it was just 2 decimal places. Okay, the next thing we're going to do calculate values of 1 over r squared. And you're going to want to think about what are the units for that. So I have to come up with a formula that takes this value of r, inverts it, takes the inverse, and then squares it as well. So I do equals 1 over, and instead of typing out 0.206, I just click on the cell with the value, and then I square it using ℝ2. I copy this down, Control-C, Control-V, or you can also use the drag feature. So you grab this box in the corner, drag it down all the way. Okay, and let's give this a reasonable number of sig figs. Let's say, whoops, let's put it 2 decimal places so that these have 2 sig figs. Okay, The next thing we're going to do is add two charts. So you go to Insert. Now in a PC, it doesn't have a Charts tab. It has Insert, and then you choose Charts. But then you find this picture, the scatter plot picture, and you want the very first one, mark scatter, no lines in our chart. And it comes up with all this crazy stuff, right? So you right click, you choose select data. There's going to be some stuff there already. Anything that you see on the left side under series, you want to remove all of the existing series. You add a new by clicking the add button. Oops. And then you have a spot where you can choose the X values and the Y values. You might have to click edit after you add. You might, on a PC, you might have to click edit before you'll get these X values and Y values. So you go into the X values. On the X axis, we want R, values of R. And on the Y-axis, we want values of E. Okay, we hit OK. You can take away this series 1. You will need to add Y and X axis titles. You can just use R. You can use the same thing on your axis titles as you've used here for the column headings. Then we're going to make a second chart, second graph. You can Control-C, copy, and then paste. Oh, nope, that's not going to work. You can Control-click then, if you'd like. So click on the graph, and then while I'm holding my mouse down, I hit the Control button, and then I let go, and that produces a copy. So I've got my raw data graph. Let's see. Chart title. Above chart, here's my raw data. And then I'm going to take this one away, make a copy again. Now I'm going to make a graph with process data. And so my process data graph, I click on a data point. For this trick, I'm going to show you to work. So if we first click on a data point, and then you see there's a purple box and a blue box. Blue stands for y-axis, purple is x-axis. I want to get this, if I go to the very edge, right, the very edge, I get a new icon that pops up, not the corner, but like in the middle. And I click this, and I drag it over. So now I'm going to put values of 1 over r squared onto the x-axis. And look at what we get. This graph over here, zoom out just a bit, the raw data graph has this like inverse square shape. You know, it's kind of hugging the axis, approaches an asymptote on the x-axis and the y-axis. But then the process data graph is a straight line. So where is this coming from? Well, if we consider the equation E equals KQ over R squared, that's the equation that tells us how strong the field is for some source charge at a distance r away. Now we know what K is. K is 8.99 times 10 to the 9. And we know what Q is in this case. For our experiment, Q was this 1 nanocoulomb charge. It was a single positive 1 nanocoulomb charge. That means we could write the equation like this. E equals KQ times 1 over r squared. In the first graph, the very first graph, the y-axis is E, and r was on the x-axis. So I could replace E with y. I can replace r with x, just like that. And so K is a constant, Q is a constant. What do we get? Well, on the first graph we see y is proportional to 1 over x squared. Oops. Like that. On the second graph, though, we start with the same equation. On the second graph, what did we have? Well, we can take this equation and write it as KQ times 1 over r squared. And on the second graph, what was on the x-axis? Or sorry, what was on the y-axis? Let me just take this equation again. What was on the y-axis was E. So that's the y. And what was on the x-axis for the second graph? It was this thing 1 over r squared. And so now you can see why we chose 1 over r squared, because we could replace the entire 1 over r squared right here with x. K is a constant. Q, the source charge, is a constant. So on that second graph, y is directly proportional to x. That's why we get a straight line passing through the origin. So now that we understand that, we're going to create a Word file with an MLA heading. You paste your data table first of all. Data table, whoops, gets copied, highlight, Control C, and then Control V to paste. There are these different paste options that can pop up so you can match the destination style. That's usually a good one. And then you paste the raw data graph. Make sure you've got your axis titles with units on the axis titles too. Make sure they're units. Paste this. Paste as picture is fine. You paste your process data graph. Here's my process data. I like to paste as a picture. And then you answer 2 analysis questions. And the 2 analysis questions that you answer, the first is identify, the shape and proportionality of the raw data graph. Explain which equation predicts this shape and proportionality. And so when we say shape, proportionality, we're talking about the same thing. The second analysis question for you is identify the shape, proportionality of the processed data graph. Explain how the equation predicts this shape proportionality. Once you do that, you save it as a PDF. So you'll do Save As, and then right here under Format, you have to go down and choose PDF. And then once you've done that, once you've saved as a PDF, and you hit Save, only then can you upload to Schoology. All right, good luck.